looks like equivalent negative charge. Both have the same shade of, so that doesn't look right, and both bonds look the same. And so it turns out, well, there are resonance forms we could draw for this. So let's draw the next one here. And, let's try one more. This last resonance form, I'm going to move a pair of electrons from this oxygen, which is the bridging oxygen, carbon. So I have three potential resonance forms. But let's take a look at this last one. The last one, a negative here and a negative here. The formal charges have to add up. There's going to be a positive formal charge. Do you see the positive formal charge? A positive formal charge would be on this oxygen here. And so would these be, hybrid structures? We just take these and mix them to get the hybrid. But would the hybrid consist of 1/3 the first structure, 1/3 the second structure, and 1/3 the third structure? No. The first two structures should be the same energy, but the third structure should be a different energy. A higher energy or lower energy?
Higher energy.
Higher energy. And if you look at this structure, does it look very good to you?
No.
No, it looks very bad. What looks very bad?
Because it has one positive and two negative.
Well, it looks very bad because of this. We'll ignore this top oxygen here. That means if these two oxygens got in a pulling fight or a tug of war for the electron, the right oxygen won and the left oxygen lost. Is that a stable scenario? No. And so this is so unstable, I don't think it's going to be much of a contributor. Before we completely eliminate it, does it look to be the case? If this oxygen were positive charge, it should be what color? Blue. Is there much blue? The hydrogen's blue, but what about this oxygen? This oxygen has a full positive charge. It should be very blue. Is it? No. It's quite green, that oxygen. And so this one's not going to be much of a contributor. In fact, it would be negligible because it's so unstable. And so we'd expect the hybrid to be these two, based on this. And so what would the hybrid structure look like? The hybrid structure would look like this. In which the double bonding electrons are spread out over both bonds. There's an electron cloud. It's like fog. It'll just spread out. Giving each of these bonds a bond order of what? What's the bond order here? Is it 1 1/3, like carbonate? No, the bond order here is 1.5. And the charge, what's the charge on each oxygen? -half. So -half plus a -half gives me a -1, the net charge. And so this would be the hybrid structure. And here, when we look at the electron density map, that's what it looks like. -half, -half. The double bonding electrons are spread out. Here. There's going to be a positive charge on the hydrogen because the oxygen is much more electronegative, so it's going to pull the electron density away. And so this would be bicarbonate here. Electrostatic map. That. Here's sodium chloride. Some more complicated molecules here. is acetic acid versus sulfuric acid here. This one